Have you ever stopped to think about color? I mean, really think about it? We're surrounded by it all the time, but how does it actually work? Well, it turns out the answer is this incredible journey into the physics of light, and it all kicks off with something super simple. So let's just start with this, a red apple. We all look at it and agree, yep, that's red. But why? What is actually physically happening that makes our brains see that specific color? Okay, here's the first big twist. The red isn't actually in the apple. Not really. The apple's skin itself doesn't just, contain the color red. What we're seeing is actually a beautiful little dance between the apple's surface, the light that hits it, and our own eyes.
So to understand the apple, we first have to understand the light that's shining on it. And that means we get to do something really cool. We're going to crack open what we call white light and see what's hiding inside.
And here is the big secret. The light you see from the sun, or from a lamp, it looks white, or kind of colorless, right? Well, that's basically an illusion. It's actually a secret cocktail of all the colors mixed together, hitting our eyes at once.
You've probably seen this before. The classic way to prove this is with a prism. You shine that ordinary white light through it, and bam! The light bends and separates, revealing this incredible rainbow of colors that was tucked away inside it all along. That amazing effect, by the way, is called dispersion.
And that beautiful band of colors that pops out, it has a name. We call it the spectrum. It's the full set of colors that make up white light. And what's wild is that these colors always show up in the exact same order, every single time. You might remember the little mnemonic from school, ROYG-BIV. Red, orange, yellow, green, blue, indigo, and violet. This is literally the palette that light uses to paint our entire world. Okay, so we've established that white light is secretly a rainbow. Got it. But how does that connect back to our apple? Well, this is where the surface of the apple itself gets to play its part in the dance. So let's walk through it. First, that full spectrum of white light, the whole rainbow, shines down and hits the apple. Now, the apple's skin is kind of like a picky bouncer at a nightclub. It looks at all the colors coming in and it absorbs almost all of them, except for red. It doesn't want red, so it reflects it, bouncing that red light away, right towards our eyes. And that right there is the absolute key to everything. We see the color that an object rejects. The apple isn't making red light. It's just reflecting the red light that was already in the sunbeam to begin with, while gobbling up all the other colors. This simple rule also explains white and black. Think about a white piece of paper. It's not picky at all. It reflects all the colors of the spectrum back at us. Our brain mashes them together and sees white. Now, a black shirt does the total opposite. It's super greedy. It absorbs all the colors and reflects basically nothing. And when no light gets back to our eyes, our brain just sees black. All right, so if the color we see depends so much on the light source, what happens if we start messing with the light source itself? This is where things get really fun. Let's do a little thought experiment. We take our red apple, which we know loves to reflect red light. Now let's put it in a dark room with only a pure blue light bulb. What color do you think the apple would look like then? The answer? It would look black. Isn't that wild? And here's why. The apple's surface is all set up to reflect red light, but there is no red light in the room for it to reflect. The only light hitting it is blue, and the apple's surface just absorbs blue light. Since no light gets reflected back to our eye, we see nothing. We see black. So this is the big, crucial takeaway. Color isn't some fixed, permanent property of an object. It's more like a relationship, a conversation between what the object's surface is made of and what kind of light is available in the room. If you change one of those things, you completely change the color we see. And now that we know these rules, we can actually use them to our advantage. We can start to control light and create any color we want using things called filters. A filter works on pretty much the same idea of absorption, but with a little twist. Instead of reflecting light, it lets certain colors pass right through it. It's still a bouncer for light, but instead of turning colors away at the door, it decides which ones get to come inside. For example, a red filter is really simple. When white light, our full rainbow, hits it, the material of the filter absorbs all the colors except red. It only lets the red light travel through to the other side, giving us this pure red light. A cyan filter is a little more complex, but the same rule applies. It's designed to absorb red light, but it lets both green and blue light pass right through. And when our eyes see that mix of green and blue light coming through, our brain perceives the color cyan. And once you get this concept, you start seeing it absolutely everywhere. the lights at a concert, stained glass windows in a church, the lenses in your sunglasses. It's all just light being selectively filtered.
And maybe the most beautiful example of all brings us right back to where we started, a rainbow. When sunlight passes through all those tiny little water droplets in the air, every single droplet acts like a tiny prism, splitting that white light into its full, glorious spectrum.
So, I'll leave you with this final thought. If color isn't really a property of an object, but just a perception that happens when light bounces off it, what color is that red apple really when you turn off all the lights and it's sitting in total darkness? The answer, of course, is that it has no color at all. It's just waiting for the light to come back and start the conversation all over again.